which means that getting the commonality right is super important. And figuring out what to do and how to design the system in case you didn't get it right is the other important piece. Whenever my guys do a system upgrade, question number one is, how are you going to get out if it doesn't work? And did you practice that? Because every once in a while, it doesn't work, and you need to get back. I don't need to keep you standing there if you want to sit down. The chief internet evangelist goes off sermonizing. It's really, unbearable. One thing I have mentioned in the past in settings like this is my big worry about something called bit rot. This is the inverse of standards that are locked in and maintained for long periods of time. It's the one where the standard isn't observed anymore and your data is all wrapped up in that standard. So example are, TIFF images or JPEG or other kinds of, simple things like that. Today, some of the older digital images that you have in your files may not be renderable anymore in whatever version of operating system you happen to be running or whatever application you're running, because somebody decided, oh, well, we don't have to support that anymore. That's 10 years old and everybody's upgraded by now, right? So there is a lot of information, especially in the federal government, that has a long, long lifetime. And technical information especially shows up that way. I didn't realize you were way over there. You were out of my peripheral vision. I apologize.
Oh,
and that's not going to work until we go like this. Okay.
So you merge a trusted federal system. So I had a question on the DNS domain name tree. Why can't we use that or something similar to that for naming clouds?
Okay, so why don't we use domain names to name clouds? Well, one answer to that is, at least it's unique. That's good. Okay, so domain names are unique, and they have that. That's a good property. You don't want two clouds to have the same name, because then you go to the wrong place. The problem with domain names is that the way it's currently administered, the domain names can disappear if you don't keep them registered. This is a purely mechanical observation about the way in which the domain name system has evolved over time. And so I am not sure, I wouldn't reject out of hand the suggestion. The point is that how do we make absolutely sure that those identifiers don't disappear on you because somebody forgot to register, they get captured and turned into a porn site? That would really be awkward, the first order. But the other thing which I worry about is that you can sit down if you want to. I don't mean to make you stand there. The other thing I worry about has to do with the identification of information, data. Some of you may be familiar with something called digital object identifiers. It's intended to be an unbiased, literally almost uninterpreted string, which is unique and maintained for a very long period of time into the future. And that the digital object identifiers and the architecture that goes with it, based on something that my partner Bob Kahn has been working on at CNRI called the handle system. The intent there is to identify information in a way which has very, very long-term resolvability. And so if we were going to deal with the cloud nomenclature and cloud identifiers and things like that, I think we'd have to build a system that we deliberately are going to say is going to last for, 100 years or more. My biggest worry is that if you have identifiers that are not stable, that you really lose access to the data if you can't find it again, let alone interpreting it correctly, because you have to have standards for interpreting the syntax and the semantics. So I don't know whether DNS can be coerced into that, or a piece of it could be coerced into that, but I'd want that property to be satisfied before I'd use it for clouds. Yes, sir?
Don McGarry, MITRE Corp. Nice to meet you. Thanks for the talk. My question is that NEAM and the cloud seem to present itself as a big bubble solution where we have healthcare record interoperability, say. That's in a big bubble.
Okay.
What is your view on connecting the edge end users, like the cop on the beat, the doctor in the field hospital, the handler in Afghanistan, into the big bubble?
Okay, so actually the first observation I would make is that in the cloud environment, an awful lot of the computation, the use of the standardization and everything else is in the cloud. So that's a good thing. Then the question is, how do I render the information to the cop on the beat? Well, it depends a lot on what instrument that he's using. And it depends a lot on what software is intended to render whatever comes back. So let me offer you a very naive, simple-minded example of a way to deal with that. One way to deal with it is to say, let's have a very thin client at the edge, use a very simple browser-type interface, and have standards for presenting the information through that engine, but not necessarily do a great deal of computation and processing at the edge. Now, a lot of people, including me, get nervous about that because, well, what if I'm not connected at the time? And, can I possibly get some data locally that I can still do something with? So there's a balance there. And one potential way of balancing this is to say, well, if I use a browser that is capable of rendering what comes in some standard way coming out of the cloud, and also has the ability to execute programs that have been downloaded in a high-level language, like Python or Java or something like that, then the browser becomes an interpreting engine, and I can load it up with executable software. But that software is supplied by the cloud. And so we get back to this possibility of having upgrades and changes and everything else supplied by the cloud and not bound forever into the edge device. Now, this is, like I say, a kind of naive notion, but it has this wonderful property that every time I execute that application, if there is an upgrade, it comes with it. It comes with the data, instead of having to worry about the application not being able to match the data that shows up. So the adaptability is pretty powerful. Okay. Yes, sir. Hey, this is part of my health plan.
Morning. Patrick Chen from Versatron. I have a question. Looking at the NEEM standard as a whole, if we adopt to it, and comparing that to the Google company, I can see all these applications, Gmail, Google Earth, all these other kinds of applications, where I'm assuming your data is in some kind of standard format. Let's assume. It
probably isn't, but go ahead.
Okay. I guess the question
why should we be any different than the rest of you?
I'm assuming it's in a standard format which allows you to use all these different applications, use the same data in some certain
Let's see. At some, I'm looking for an analogy here. Everybody kind of understands the layered structure of the internet, and it's like the OSI layered stack. So we have commonality in a lot of our systems, but the commonality is sometimes below the level of the interpretable data. So big table is a way of having large quantities of data scattered across large numbers of machines, and the data being maintained compatibly, consistently. But the interpretation of the data may actually be the job of an application. Not every application knows how to interpret data in every other application. So we don't have commonality, but we have uniformity, but we do have commonality. Like KML for Google Earth is a common API, and it's a standard representation, and lots of people put their data into it. But we ain't where you might be wanting to go. But let's assume that it's standard. Okay,
well,
then what?
The data is somewhat standard somewhere.
Right.
So my question is, throughout the progression of the company, how many times has this standard been tuned or modified? So hopefully we can get some insight.
Okay, this gets to the how do I flexibly upgrade and change things. So that actually, at the underlying level, the kind of the big table sorts of things, several times we've gone through 3 or 4 iterations of how we distribute data, how we replicate data, how do we maintain data consistently, and so on. But at the interpretation level, not as much, I don't think. So this still gets to this core question, which I believe is hidden in your question to me, is whether or not the NEEM concepts give us enough forward flexibility so that A, we can deal with backward compatibility, and B, we can keep extending the functionality of the system. I don't have a magic wand to offer you from Google. I wish I did. I don't. At least I'm not aware of it. But the question is exactly the right question to ask. So coming back to my earlier comment, asking the right question helps a lot. That's one of them. Yes, sir. Isn't that a dirty trick to answer the question by saying, boy, that's sure a good question? Yes, sir. Please tell me that that's not swine flu.
It's not. It's avian.
Okay.
Okay. Kurt Cagle, O'Reilly and XML Today. Have you had any thought about where technologies like xQuery and other related W3C pieces fall into the NEAM standards?
Okay. So first of all, I will admit to you that I don't know enough about xQuery to give you a coherent answer. So I will honestly tell you that I'm not going to make up an answer. W3C is a very important part of our universe because people there are struggling with how do I use the web and how do I build applications and standards to operate. But I don't know the answer to that. Now, you know about xQuery apparently, or you wouldn't have asked about it. So tell me, what's your sense of its importance?
Well, I think it's huge.
Okay. So tell us why.
Primarily because it's a mechanism.
Use the microphone so everybody can hear you.
Okay, sorry.
If you're going to make an idiot out of yourself, you might as well do it,
Okay.
you know.
I'm remarkably skilled at making an idiot out of myself.
Hey, I've been doing it for 40 years. I have a lot of experience. Go ahead.
Primarily because xQuery provides a mechanism to do query and additional XML database operations on pretty much any kind of XML structure.
So let me probe. I mean, we'll get down to a level of detail that people may not be interested in. But one important thing from my point of view in the cloud context is whether the way in which you express a query in xQuery, which I don't, about which I know nothing, does it allow itself to be propagated across a large number of processors that are going to compute the response to that query? Can it be done in parallel? Because otherwise, if it makes the assumption that there's this one single processor that's running at 70 gazillion MIPS per second, then that's not a good match to the way in which we have to do processing in the cloud.
No, actually, it is a language that's designed to work both on a single application and with a distributed architecture.
And what about the gathering of? Is there any implication about the xQuery framework that also allows you to gather the answers back and correlate them?
That largely depends upon the implementation.
Okay. Yes, the devil is in the implementation
the
details.
devil's always in the details there. But
okay.
Yes.
All right. Thank you.
Thank you.
I don't see anybody else asking questions, so I think we must have come to the end. Madam Chairman, over to you.
Thank you very, very much.
Thank you.
I've had a second career high now, so I should probably retire from the government after my 3 years. Some logistics for you. We are going green here at this event, so there's no printed agenda. The agenda at a glance is in your little portfolio, and there are computers out by the registration desk that will also show you the agenda. Visit the NEAM Cafe for the complete online version. Follow us on Twitter. Tweet about us. Don't twit about us. Just tweet. And use the hashtag NEAM NTE. We'll be gathering those up and creating a tweet book, which we'll distribute after the conference. And join us. Ooh, that was from last night. You could have joined us for the reception, but that was last night. Is that it? Or anything else? Okay, so we're going to go to break now, and the sessions begin at 10:15. So you've got a short break and then run to your sessions.
Great. Thank you. That was good fun.